So here we have AES expansion code. First we have the rcon table value, which is 1, 2, 4, 8, 10, 20, 40, 80, 1B and 36. Here we have also added 4 more values to cover 256 into 256 bytes also. Next, we have the sbox with the constant values. Every time it will be the same for AES expansion. Next, we have taken a key function for calculating key. Here, number of row is equals to 4, number of column equals to length of key divided by number of row. As we know, every key has consists of 4 bits, and the length of key can be 128, 256, and 192. So different time the number of expansion or key value will be different. Next, we have number of rounds. Here the formula is number of column plus 6. If we assume number of column equals to 4, then 4 plus 6 it will be 10. Then the number of rounds will be 10. Finally, we will have to take a initial round key. For initial round key, we have run a for loop inside an array. Then the for loop will run from 0 to length of key to 4. Like the value will be 0 to 0, 1, 2, 3, and every time I will create a um, this I this I value will create a group of sets of each 4 value. Like if I equals to 0, then the value will be before 4, like 0, 1, 2, 3. And if I equals to 4, then the value will be 4 plus 4 equals to 8, and then the final value will be, then the key value will be 4, 5, 6, 7. This is how the round initial key is calculated. Next we have a for Next, we have run again a for loop, which is which is for sub calculating subkeys, and the formula will be a number of rounds plus 1 into 4. Here, number of column is, as we know, number of column will be calculated. We have calculated before. If we take number of rounds will be 10, then 10 plus 1 equals to 11, and 11 into 4 will be 44. There will be 44 subkeys, and like 0 to 43. Next, we have a temp variable for round key, like I minus 1. I is the initial value, and I minus 1 will be the last sub key. Here we have taken the last sub keys. Then we will divide I with number of column. Then it will show the 0 value. Next we will do the left circular shift, and we will convert temp 0 to the left side, and substitute temp 1 to 4 value to the right side, and it will exchange their sides. Next we will do is box. Then next we will substitute the value of temp variable with sbox value. Here we have taken a b variable. This is how our function is done. Next we will do rcon table value, which is we will take a rcon table value I and divide it with number of column. Then we will do the function minus 1, and it will show the value of temp 0, which means first column's first value. Till now we have uh, initiated w0 to w3, and now we will make w4 to till the last sub key, like w43. For new round key, we will run another for loop, which will be I minus number of column, and this means we will do Before progressing, we will do a temp 0 rcon table divided by n column minus 1 XOR operation with the temp 0 value, and we will then next progress to the next function. We will do um, new round key value. Then we will make XOR function with the current key with previous sub key, and we will append the new round key with the uh, existing round key. Here there will be new round key every time, making new sub keys. Then the round key will be returned, and here we have taken the array as hexa string. Here we have a value which is in string, and we have also a array. We will run a loop in for we will run a for loop in hexa string, and it will make value every time by iterating 2, and there will be I plus 2 till 16, 0 to 16, and this will append every time. Finally, we have a value in which is in a hexa string, and we will convert the value to array, and then making the string, we will get the expanded key with key expansion. Finally, we have the round key string int array value, and we will generate w each time, like w0 to w43 for 44 subkeys, as we know, and the value will be printed in hexadecimal form. This is how AES expansion code, its expansion is done through code. Now we will run the code. As we can see here, the W subcase is generated till for W43. That's all for our AES expansion code.